Why are we here? It's a question with both philosophical and physical considerations. For the latter, we can also rephrase just slightly to, how are we here? And that's one of the most important scientific inquiries of all. So let's take a closer look at the incomparable story of human evolution, from our time as ancient primates to our becoming the dominant species on this planet. And then let's go back even further, exploring what existed before humans and what our planet was like in its earliest days. In the vast timescale of Earth's entire history, modern humans are relative newcomers. Our species, Homo sapiens, has existed for approximately 300,000 years, which might sound like a long time, but it represents only a slither of Earth's 4.5 billion year life. The beings that would eventually become humans grew up and developed with and alongside various other primates at various other times. Our evolution can be linked back to a common ancestor we share with chimpanzees and bonobos. Key moments in our particular story, however, include the development of bipedalism, the enlargement of our brains, and the emergence of Homo habilis, an early hominin that's thought to be a direct descendant. Next came the mastery of fire and the development of sophisticated tools, all culminating in the emergence of Homo sapiens proper in Africa somewhere between 300,000 and 200,000 years ago. It hasn't all been plain sailing. Humans have faced several near-extinction events over the course of our couple of hundred millennia. One of the best-known examples is the Toba supervolcanic eruption around 74,000 years ago, which researchers believe may have caused a volcanic winter and led to a dramatic decrease in the human population at the time. It's even thought by some that numbers may have dwindled to just a few thousand in the years following Toba, showing just how close our species almost came to dying out. It's a pattern that Earth has seen before, though, and again, the time of humans is extremely short compared to everything else that preceded us. To really get a grip on things, we need to journey back billions of years to the formation of our planet. Around 4.5 billion years ago, the Earth formed from an ancient swirling cloud of dust and gas. The young Earth was a hostile place, bombarded by asteroids and comets, with a scorching surface covered in molten rock. But over time, the planet cooled, and the surface began to solidify. After that, life emerged relatively quickly in geological terms. The oldest evidence of life dates back around 3.7 billion years, meaning that something has lived here for the vast majority of the time that Earth has existed. These early life forms were nothing like us, though. They were simple, single-celled organisms, and they thrived in the oceans. Earth's waters weren't laid out in the same way that they are now, but they were still crucial, a breeding ground for the very first things to call this place home. Over eons, life evolved and diversified, gradually giving rise to more complex forms. Things like algae, simple multicellular organisms, and invertebrates were next in line. The first complex animals, such as early jellyfish, appeared around 620 million years ago. And then came the Cambrian explosion. Around 530 million years ago, this marked a pivotal period in Earth's history as a whole, as is witnessed by a massive and sudden proliferation of diversity. From this point forward, life came in many, many different forms. And while the exact mechanism that triggered the Cambrian explosion is unknown, it ranks as arguably the most influential stretch of time that Earth has ever seen. That said, the next chapter is probably the most famous that Earth has written so far: the dinosaurs. Dinosaurs dominated during the Mesozoic era, which lasted from around 252 to 66 million years ago. However, alongside all of the ferocious giant lizards, there were small, unassuming, shrew-like mammals quietly carving out their existence as well. And these are crucial for us, because after the mass extinction probable asteroid that wiped out all the non-avian dinosaurs, those tiny mammals rose up. They diversified like crazy and quickly filled all the freshly opened ecological niches. From here, and between 60 and 55 million years ago, primates entered the fray, rapidly evolving from their mammalian ancestors. The earliest primates were small, tree-dwelling creatures, but importantly for us, they had forward-facing eyes and complex, grasping hands. Now is when the human begins to appear as primates over time, developed and specialized into a variety of forms, including, eventually, Homo sapiens. And that's pretty much that. A brief timeline of the ultimate saga, life and evolution on Earth. Except for some, there could still be more to it. And while yes, the Cambrian explosion is significant, and the end of the dinosaurs is vital, there may have actually been another pivotal point to which everything else is anchored: the arrival of alien life. The concept of ancient aliens suggests that extraterrestrial beings may have played a major role in Earth's history, potentially influencing how species evolved, including humans. Proponents point to various apparent mysteries in ancient times, such as around the construction of the pyramids and the creation of advanced civilizations like the Sumerians. We've covered in past videos the problems that such views entail, including seemingly entrenched prejudice and a refusal to acknowledge modern findings. But nevertheless, the belief in ancient aliens is increasingly mainstream. Perhaps its popularity is tied up with some other key considerations, including the Fermi paradox. The question of why, given the vast number of potentially habitable planets in the universe, we haven't yet detected any signs of advanced extraterrestrial civilizations. Is it because we're only here because the aliens have placed us here, at a distance from themselves? Or indeed, are we yet to find aliens because actually we are the aliens? We also have the theory of directed panspermia, which argues that any advanced enough group would purposely contaminate other worlds and star systems. To a very small degree, it's what we may have already done via the Apollo trips to the moon and our ongoing rover missions to our closest planets. But also, ancient alien theories might suggest that rather than facilitating panspermia, we're the result of it. As to how that broader framework would fit into everything we know about evolution to this point isn't clear. What is clear is that however you view it, in the grand tapestry of Earth's history, humans represent only a tiny, tiny thread. Conventional science says that before us, the planet saw the rise and fall of countless other life forms, from single-celled organisms to massive dinosaurs. Alternative speculation suggests that aliens might have had something to do with it. But finally, you might wonder, why does any of it really matter anyway? We're here right now. How we got here is besides the point. But actually, understanding what came before humans is not just an exercise in satisfying curiosity about the past. It has profound implications for our present and future. By understanding our origins, we can appreciate the interconnectedness of life on Earth today and the complex processes that have shaped us and everything else. Knowing how we came to be, we can better grasp the incredible diversity that exists in our world, which is essential knowledge for conservation, but also in maintaining the future health of humankind itself. If we can track the key moments and adaptations that led to our emergence, then we can better trace the development of traits such as bipedalism, brain expansion, tool use, and complex social structures. And lastly, we can use all of that, all of what we know about ourselves, in the continued search for extraterrestrial life away from planet Earth. There is little reason to suggest that alien life would look or be anything like human life. But that's why knowing how we got here is important, because it allows us to backtrack and explore all of the other directions that life might have taken. In the meantime, of course, human evolution is ongoing, and the question of what will come after humans, or at least after today, is very much up for debate. Where do you think we could be headed? Because for now, that's the story of where we came from.